Hi everyone. Today I'm going to share about the project that we working right now. It is a decentralized random number generator. And um, before we enter the presentation, I want to share about myself a little bit. Back in time, I work as the R&D engineer at the first blockchain lab in Vietnam. And my main research and my topic in research is about random number generator and how we build a decentralized random number generator um, on blockchain. Uh, After I left the, the the blockchain labs, joined another startup and also play the role the solution architect for Trust. And right now, I'm a founder of the Origin Network. We build the infrastructure for decentralized gaming and metaverse. Okay, so we're going to go through the history of the RNG. So random number is plays a very important role um, in the computing and also in the gaming and also gambling because it is people always need a source to draw the value, the result to decide who going to win the game. And also the random number generator players like very important role in the cryptography. Like people need to the random number to generate the the key pair, like the public key and the private key. So it is very important that you always need a source of the randomness. So in the history, there are many kind of like the sort of randomness. People try to use the physical sort of randomness, like you roll the dice and then you get the result. And also you can use the human at the sort of randomness, like you can tell people to give you a number. And to 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 help to bring the randomness into the computing. There are many solutions like collect the noise, collect photon on the webcam or on the camera to generate the randomness. And also there are many issues with like the concept of true randomness and cryptography randomness before. Like people try to inject the backdoor into the algorithm that generate the randomness to control the randomness. By controlling the randomness, they control the game and also they control the gambling and other stuff that beyond that's the randomness. So there are many scandals about the random number generator and it is a centralized, either parts of the centralized RNG. And right now, even the team like the OpenSSL team and another cryptography team, they going to implement the library and they not even trust the solution from Intel and another company because they do not trust the people going to actually give you the power to generate the randomness. So in the couple of years recently, so people talk about how we can secure like the trustless randomness and how we can create the random beacon. So its application is very important because right now when you take a look into the Polkadot and the Polkadot is now using the VRF to get the randomness and by the brawl the done randomness to choose who going to shoot the block. So um, the randomness is very important. And I think in the future, in the like in the metaverse, the randomness, the source of randomness is much more important. Like you need the source to decide every the logic in the game. When you need the random logic, for example, when you play the game in the metaverse, and you need to decide who going to win like just like the poker, and you need the randomness um, to decide who going to get like the relate their card, how people sub the deck. So the point is there are no sort of randomness right now, like the trustless sort of randomness, because there are several approaches, like you can see here the random, like the very first concept of the randomness generator, on-chain generator. Every people going to contribute their randomness, and another event solution by Cloudflare. They provide like DRAM concept, allow people to participate in the like the multi-party computation to generate the randomness. And I really love this concept, and we do also take a look into their implementation and how we could learn from them to improve our own protocol. Another approach is using the verifiable random function, and there are many projects using it right now, like Chainlink and another project. Um, there are another approach like using the verifiable delay function, and this was proposed by Vitalik, and is it about you compute the randomness, but you cannot know if you do not do the work. It's just like uh, people are meaning do the meaning right now, um, and you need to. It is it's some sort of the proof of work approach, and it will cost the computation power. And another approach is the coin tossing protocol, but I think it has some trouble with the secret withholding, and also the bias of the process. And that's why I think Cardano will not public the whole the whole paper, scientific paper about the coin tossing protocol. And so we're going to take a look into the very like simple concept that people will going to use to to implement it in the rundown. And we're going to take a look into it and see what is the problem with the decentralized random number generator. Um, so for example, we need a participant like from P1 to Pn. They're going to generate the randomness with their own sort of entropy, and then they're going to commit the result to commit the digest of the result to the blockchain. And up, oh, after that, they're going to reveal their secrets, and we can compute the secret. The problem is, uh, mm, the problem is if there are like a cheater, he can hide the secret. So he going to have another chain to win. So that's why this approach maybe have some trouble, because the last people who going to review, he can decide to review or not. So we take a look into it and we see the problem here. That the first issue is about the colluding party, and people like they create a group of people and they control and manipulate the result. And another issue is about the secret withholding. Like one people, the last who going to reveal the result, he going to keep the secret. And every random module, they will base on the fail stop. So when he's drop his collateral, and then he have another chance to win. So so another issue is about nothing at stake. Like even I'm an honest participant in the protocol, I easily get like convinced by the concluding party to give them my secret, because there are no penalty applied to the applied to participant when they reveal their secret uh, or follow the malicious action from the colluding party. So here is the very first like improvement from Sergey, and he's going to create a group of people who control the secrets. So by using this approach, uh, we need a group of people to control the secrets. That's why if they're going to withdraw their secret, like they perform the secret withholding, the whole the, the whole group will going to get the penalty, and then they will lose the huge collateral. And this approach is very like um, very good improvement and is secure the process of the copy scheme. But if the value of the rewards of that process, like there are some $1 million lottery, so people still able to drop their collateral to have a higher chance to win. So this improvement will have some problem with the game theory to solve the game theory problem. So we introduce a new way to solve the issue, like we allow people to generate a secret, and also they're going to split the secrets by using the publicly verifiable secret sharing. By this process, we're going to create a temporary black box, and the share will broadcast among people in the network, and this will reduce the chain as they are a concluding party, and even they are concluding party, they're going to lose huge collateral, and the collateral they lost image equal to the bright pool. So this approach allows the share to distribute among every node in the network. So in our approach, we use a VRF to generate randomness and use a PVSS to split the randomness into share. And we secure the broadcast process with the gossip based protocol. So in the end, every people will know about every share that people create by using the PVSS, and they can reconstruct the randomness. So we are going to implement the POC right now. So um, we do the bandmask and also have the valuation on evaluation on the POC. So this protocol do not prevent people to create a concluding party, but if they are an adversary and they create a colluding party, they're going to lose their collateral. And they we also prevent the secret withholding because people need to learn about every share to collect enough the information to reconstruct the secrets. And after we do the audits and also do the employment, we're going to share the result with you guys on our GitHub. So here we going to here is how we could build up the process and how we implement it. The first thing is about the peer-to-peer network. It's going to establish the communication between the participant and also uh, allow people to broadcast their share to another nodes, and people in this peer-to-peer network can verify the share of the participant, and also um, and then also build up their knowledge about the state of the network. And the one-way payment channel allow people to apply the penalty on every share that uh, um, they're going to split multicast to the network. And here is the how we integrate with Polkadot. Like every every parachain will able to every consumer chain can get the randomness from the peer-to-peer network, like the randomness, like the RT, DRNG, and here is the sequence diagram. So the first process, people like the participant need to deposit the collateral to the host parachain, and this is the process, and they going to await for a request from the consumer parachain, and then they submit the share, collect the share, and reconstruct and submit the result. So the process is simplified um, to to this sequence diagram. But actually, there are more stuff need to be done. Like we're going to establish the one-way payment channel to allow the people to apply the penalty on the cheater. So here is the example of the distributed encrypted share. So a dealer going to like generate the share from their secrets, and every time they gossip their knowledge, they need to gossip the proof and also the encrypted share and the proof that allow people to redeem if they can prove that the dealer is a cheater. So right now here is the comparison with the two major solution. Um, like we have several uh, points to compare. The first thing is about decentralization, and um, we actually can improve this, because right now even for DRAN they need a group of like 10 entity to generate the randomness for the whole the whole network. Just nine of them, and actually the nodes have no incentive and also no penalty if they form colluding party. Um, Actually, we do the implementation, and it's already available in our GitHub. And also, we also public about our protocol. Um, um, and right now, our next step is implement the smart contract that can verify the on-chain proof, and also improve the broadcast process, and how we integrate with the Polkadot and leverage the Polkadot security to establish a multi-chain sock of trustless randomness. Okay, let's let's get to the Q&A section. If you have any any question, please let me know. Okay, um, thank you, you guys. So right now we actually work on like the Origin network, and we want to build like the the network allow people to build application and also build a distributed application, build a metaverse application, and we working on the several component of the network right now. And the process is in the very early stage, and we also searching for the investment, and we're going to public the white paper soon, and also public the scientific paper about the DRNG, because right now we do the um, a lot of research about cryptography, and also how we use the cryptography to secure the wormhole, and also the random number generator. And we want to uh, the first project that's developed the multi-chain shock of trustless randomness.